Assalamualaikum warahmatullahi wabarakatuh. In this video, I will proceed to discuss example from the exercise 1 part B. So you are given the function f(x) is equivalent to 2 over negative x plus 1 minus 3. So what we have to do first here is we need to determine the basic function. So y is equivalent to 1 over x. So basically this is the reciprocal function where the function is 1 over x. So this is our basic function or the first step. And then the second one, we have to determine is there any horizontal shifting. So we do have x plus 1 here, and we know that the negative sign shows that there is a reflection on the y-axis. So the first transformation technique involved here is y is equivalent to 1 over x plus 1. So the transformation technique here is shift left 1 unit. Then the next one, we have here the factor 2. So we can apply the stretch or compress or the reflection. So let me apply the stretch or compress. We have a factor of 2 here. So the function of 2 over x plus 1, we can rewrite 2 over x plus 1 is also equivalent to 1 over x plus 1. So if we put in this form, you can see clearly actually the factor of c is outside the function. It is in the form of y is equivalent to c of the f(x). Therefore, when the c is outside the function, so it should be vertically. And when it is vertically, when your c greater than 1, so the transformation technique involved here is stretch vertically by this factor. So in this case, we put the function first. Y is equivalent to 2 over with the x plus 1. So we have to write down the transformation technique. Stretch vertically by factor 2. Then the next transformation technique, we have a reflection here, and since the negative is inside the function, therefore we have to reflect about y-axis. So let me put here number 4. Y is equivalent to 2 over negative x plus 1. So the transformation technique here is reflect about y-axis. Then the last one, we have here vertical shifting. So the negative 3 at the back shows that the graph will moving down 3 unit. So the function here is y is equivalent to 2 over negative x plus 1 minus 3. So we have to write down the transformation technique. Shift down by 3 units. So this is all the transformation technique in this function. So all this statement is compulsory for you to write down. So you cannot just write down the function, you also need write down the transformation technique. Then the next step, we will sketch all the graph. So starting with the basic graph, together with the 4 transformation technique, all together we should have 5 graph on our solution. Okay, let us sketch our graph here. So the first one is a basic graph with the function y is equivalent to 1 over x. So how the basic graph of reciprocal looks like? So for the reciprocal, we have 2 graph, or it is divided into 2. This is y and the x-axis. We have the graph above the x-axis, and we also graph below the x-axis. And the point that you choose here must have 1 point from the above axis. So we have above our x-axis, so the coordinate here 1, 1, and this one should be negative 1, negative 1. Okay, so one of the important properties for the graph of reciprocal, since the function in form of rational function here, so 1 over x, meaning that the values of x, we can see here x cannot be the values of 0. And actually, originally, the y also cannot be 0. Why x cannot be 0? Because when your x is 0, the function is undefined. When your y is equivalent to 0 also, the function is undefined. Therefore, our graph, originally, it will never touch the line x is equal to 0. So, where is the location of x is equals to 0? So, it is on exactly on our y-axis here. So, this is the line and the line is referred to the vertical asymptote, and we denote as a VA. So, the line of the VA originally at the values x is equals to 0. And then the line on our x-axis here refer to the horizontal asymptote, and this graph will never touch the vertical and also horizontal asymptote. So for the horizontal asymptote, we denote as a HA. So y is equals to 0. Y cannot be 0, x cannot be 0, but when we mark the values of y and x on the graph, we have to put y equals to. So we are referring to this line. So this line refers to the horizontal asymptote, y is equal to 0, and the vertical asymptote, x equals to 0. So this vertical and horizontal asymptote will change or will move as your graph move to the left or to the right, or as your graph move up and down. So it is not static on the line y and x is equals to 0. Okay, so see what happened on our next graph. So our next function is y is equals to 1 over x plus 1. So when we sketch the graph, so there is a horizontal shifting where the graph will shift to the left 1 unit. This is x, this is y. So when you're looking at to this function now, our x cannot be the values of -1. Therefore, the new vertical asymptote, we must have to draw using dotted line because that is referring to the asymptote, and the horizontal asymptote unchanged because there is no movement up and down on the second step. So our graph will be something like this. So this is our graph, and then the other side is here. So the coordinate of 1, 1 will become 0, 1. So the new coordinate here is 0, 1, and the new coordinate here is -2, -1. So we have here -2, -1. Okay, so you have to label the asymptote here. So vertical asymptote is the line x equals to -1. Then the next graph refer to the function y is equivalent to 2 over x plus 1. So just now we have discussed there is a stretch vertically by a factor of 2. So the coordinate of 0, 1, so let me put here the original coordinate from the previous graph. We have point of 0, 1 and -2, -1. So for the next step, when our graph stretch vertically by a factor of 2, so vertically meaning that the changes on our y. So every y we have to times with 2. So you will get the new coordinate here should be 0, 2, and the new coordinate here should be -2 and -2. So next we have to sketch the graph. So the graph here will be something like this. So the shape is still the same like our previous step. So we have the vertical, since our vertical asymptote is the coordinate of x, so the changes for the stretch vertically, the changes on y, therefore there is no changes on vertical asymptote on the third graph. So on the third graph, we need to draw first the vertical asymptote. It is important for you to draw the asymptote first, then you draw the graph. So if you draw the graph first, then you draw the vertical asymptote, there is a possibility for your graph to touch the vertical asymptote. So for this one, it's better for you to draw the vertical asymptote line. We have vertical asymptote on the line x is equivalent to -1, and the coordinate of 0, 1 now will become 0, 2, and the coordinate of -2, -1 just now will become -2 and -2. So this is the new coordinate, -2 and -2. This is y and this is x-axis. So let's move on to the next step. On the fourth graph, the function is y is equivalent to 2 over -x plus 1. So there will be a reflection on the y-axis. And when you sketch the graph, so the graph originally from the previous graph, so when it is reflect on the y-axis, this graph will move to the other side of your y-axis, and this graph will move to the other side of our y-axis. And since our asymptote is on the line x is equal to -1, so the vertical asymptote will also reflect on the other side, because when we talk about reflection, the changes on our x values. So from the previous coordinate, which is -2, so let me put the first coordinate is 0, 2. So the coordinate of 0, 2, since you will reflect on the y-axis, so the changes in x coordinate. So 0, 2, of course there is no changes because it is exactly on our y-axis. And then the coordinate of -2, -2. So the coordinate of, we have here the coordinate of -2, -2. So when you reflect to the other side, so the coordinate of -2 will become +2. So the changes in x. So here 0, 2, and this one will become +2 and -2. And our asymptote also change. So vertical asymptote will change to the x is equals to 1, because when you reflect on the other side, so x is equivalent to -1 will become x is equals to 1 on the fourth graph. Okay, so let us sketch the graph here. So we have this axis. So now the new vertical asymptote, as I mentioned just now, is better for you to sketch the new asymptote first. So this is our new vertical asymptote, and please make sure you label all the asymptote. For this previous graph, you can also put as HAY equivalent to 0. This one remain also HAY is equals to 0. So now our new graph, so even though the coordinate remain, but the graph will be on the other side. So we have here the new graph will be something like this. And then the new graph for the other side should be something like this. So the new coordinate here just now is 2, -2, and the coordinate of 0, 2 remain, but the shape of the graph should be opposite. So this is the new graph on the fourth function, so which is 2 over -x plus 1. Now let's move on to the last graph, which is y is equivalent to 2 over -x plus 1 minus 3. And we have decided just now the transformation technique is shift downward 3 unit. And originally, so on this case, our horizontal asymptote here is y is equals to 0. So when there is a -3, it shows that there will be a horizontal, there will be a vertical shifting, meaning that your graph will moving down 3 unit. And our horizontal asymptote exactly y is equals to 0. So since your graph will move down 3 unit, the horizontal asymptote also will moving down 3 unit. So the previous graph, there is no changes on the y, because on the second and on the third, fourth graph, there is no changes on y coordinate. Therefore, the horizontal asymptote remain as y is equivalent to 0. But not on the final function here. So there is a vertical movement, shift downward 3 unit. Therefore, the new horizontal asymptote is y is equivalent to -3, and there is no changes now on the vertical asymptote. So this one, vertical asymptote is x is equals to 1. So what you have to do first here is you need to sketch the asymptote first. So it will be more easier for you to sketch the graph. So we have here the vertical asymptote. On the line, x is equals to, vertical asymptote x is equals to 1. Okay, so let us draw the new horizontal asymptote here. So this is referring to the line horizontal asymptote y is equivalent to -3. So the new coordinate for the 0, 2, so 0, 2 will become 0, -1. So we will have something like this. So this is the coordinate of 0, -1, and the coordinate of 2, -2 will become 2, -5. So it should be below our horizontal asymptote. So this is the line of 2, -5. So this is our vertical asymptote, x is equals to 1. So this is the final graph of the function fx is equivalent to 2 over -x plus 1 minus 3. And then from here, what we have to do here is we have to determine the domain and also the range. So how to determine domain? You have to look at from the left to the right. So the domain, and if you look at to the function, we can see that the domain is from -infinity until the values of 1 union 1 until infinity. So let's put the answer here. So the domain of this function is -infinity until 1. And how about the range? We have to look at from the bottom to the top. So the first values of your y is -infinity until the asymptote. So that's why it is important for you to sketch the asymptote, so that you know your graph will never touch that line and it will stop there first. Therefore, we have -infinity until -3 union -3 until infinity. So this is the domain and this is the range of this function. So we have here y is equivalent to -3. So and vertical asymptote x is equivalent to 1. So when you already have the correct vertical asymptote, it will be more easier for you to determine domain and range. So for the domain, you can also look at from the last function here. So 2 over -x plus 1, so x cannot be 1. So x cannot be 1, meaning that the domain will be from -infinity until 1 union 1 until infinity. But for the range, you cannot just determine by just looking at to the function. So we need to have the graph, then you can determine the correct range. So you have to make sure your graph is correct, then you will get the correct range and also domain.